Welcome to the solution video. In this question number 1, we have been asked to draw the graphs of these two functions, and they have given only the positive y's. That means there is a possibility that we'll not have any negative y. So let's see. And the easiest way to check that and to draw the graph is this mathematical one. There are some other, but I find this one the easiest. So draw a table, write x here, then write one of the functions here, 5 plus 3x minus 2, which is actually the y value. Can you see y equal to this? And I wrote actually y here, but because I have x here, I will substitute x in this one. Second, I will write second graph. So second one is 11 minus x, the y value. I will write it here. Now I will substitute x into both of them one by one. From where? From minus 6 till positive 6. So let me write all the x values here. Here it is. I could have just written 2 or 3 points which would give me good linear graphs, but they are having 4 marks for this, so I don't want to take any risk of not getting any particular point on the graph. So that's why I wrote all this. So let me substitute one by one. Let me give you an example and then I will do it fast. So let me substitute minus 6 in this first y value. Okay, so it is 5 plus, so let me do it here, 5 plus absolute 3 times minus 6. In place of x, I will write minus 6. 3 times minus 6 is minus 18. And then we have minus 2. So it becomes 5 plus minus 18 minus 2 is minus 20. And 5 plus 20 is 25. Why plus? Because absolute makes everything positive. Whatever is the sign inside does not matter. It becomes positive with absolute. So 5 plus 20 is 25. So I will write 25 here. Similarly, here I will write 11 minus 6 because x is minus 6. That becomes 17. Right? And now let me show these 2 points and then I will continue with others. Minus 6, 25 is for the first one. So let me show that with this color. 25 is somewhere up here out of this graph. Then we have minus 6, 17 for the second one. Second will be minus 6, 17 will be somewhere here. Right? So let me continue with red and blue dots and I will keep on putting numbers here. And now the whole table was complete. I marked all the dots on the graph. I got a straight line, blue line for the second one, but I got a V-shaped graph for the absolute one, but I did not get any vertex. So to get the vertex, I will just extend this here and see where they meet, and that completes the graph. They are not asking us to find the critical point, where is this meeting the any level of y or what is the value of x. They're just asking us to draw the graphs. We have done that. Okay. Now the second part says using the graphs or otherwise solve the inequality 11 minus x, which is the second one, less than the 5 plus 3x absolute 3x minus 2, which is the first one. So we have to see where the graph of the second equation, which is blue, lower than the graph of the absolute one, and we can see it here. At this particular part, red is above blue, so this will be the point beyond which we will get a red graph above blue graph, which is according to our question. And now question is, what is this point? Right? Similarly, there is a second point after which this is above blue graph, but we clearly see here at x equal to 2, both are 9. So this one is clear to us that if x is greater than or greater than 2, yeah, 3, 4, 5, 6, these ones, if x is greater than 2, this this particular inequality is correct. So this answer is very clear to us. We can also see that it is at minus 2. Both are 13. So they are crossing here. X is minus 2. Right? And red graph is above blue graph here, which is x is less than minus 2. So these are the two solutions. They said using the graphs or otherwise. So graphs give us the answer. We are ready with our answer. First answer is x is greater than 2. Second answer is x is less than minus 2. So this is our inequality which we will write here. So 11 minus x is less than 5 plus, let's write positive first, 3x minus 2 is positive. Second, 11 minus x is less than 5 plus, rather 5 minus. We have to change the sign of 3x minus 2 because it is inside absolute. It is positive or negative, we are not sure, and that's why we have written it once positive and once negative. That's what we do with absolute. Let's me solve both and we will write both the answers. 11 minus x is less than 5 plus 3x minus 2. Let's bring this 3x to the other side. Minus x minus 3x is less than this minus x and this minus 3x. 11 will come to the right side, which is 5 minus 2 minus 11. So it becomes minus 4x is less than 5 minus 2 is 3. 3 minus 11 is minus 8. Divide both sides by minus 4, and whenever we divide an inequality by a negative number, sign changes. So minus 4 and minus 4 cancel, x is remaining, but sign will change. Minus 8 divided by minus 4 is 2, and yes, this was the solution already known to us, this one. That means the other one will give us the correct answer. We need the second one. So let's do it. 11 minus x less than 5 minus 3x plus 2. So minus 3x will come to the left. It will become 3x minus x less than 5 plus 2 minus 11. And this becomes 2x less than 7 minus 11 minus 4. And x is less than, divide by 2 here, divide by 2 here. Since we are dividing by a positive number, no need to change the sign. X is less than minus 2. So these are the two answers. X is greater than 2 and x is less than minus 2. These are the two solutions using graphs or otherwise they said. Question 2, A part. Expand this one, evaluating all of the coefficients. So they've not said in what order, so let's start with normal order. It will be 4c0 and 2 to the power 0 minus 3x to the power 4. That will be the first term. Then we increase it by 1, 4c1, 2 to the power 1 minus 3x to the power 3. So this power went up by 1, this power went down by 1. Then 4c2, 2 to the power is 2 minus 3x to the power 2 again. The sum is always 4. Total is exponent is 4, so their sum should be 4. 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, plus 4c3 is 2 to the power 3 minus 3x to the power 1. And finally 4c4, 2 to the power 4 minus 3x to the power 0. They're saying evaluating all coefficients, so we have to evaluate everything. 4c0 is 1, 2 to the power 0 is also 1, but minus 3 to the power 4 will be positive 81, and x to the power 4 will be x to the power 4. So very key idea here that whenever there is an exponent outside, it applies to both the participant if they are multiplying. It does not work if it was like this. Okay, if it was like this, then we would do something like this. So only if they are multiplying inside. Next, 4c1 is 4, 2 to the power 1 is 2, minus 3 cube will be minus 27, x cube is x cube, 4c2 is 6, 2 square is 4. Minus 3 square will be positive 9, and then we have x square. 4c3 is again 4. 2 cube is 8. Minus 3x to the power minus 2 to the power 1 is just minus 3x. 4c4 is 1. And 2 to the power 4 is 16. Minus 3x to the power 0 will be 1. So, what do we get here? 1 times 81x4, 81x to the power 4, plus 4 times 2 is 8, and 8 times 27 will be 5621. And negative, not positive, because 27 is negative. X cube plus 24 times 9, again 216, x square, 32 times 3, 96, but negative 96x because of this negative. And 1 times 16 times 1 is 16. Voila, we got all of them. Next, the sum of the first three terms of ascending powers. In ascending powers of x, in the expansion of this. Okay, so we did not expand in ascending powers of x, but it's okay. We'll count from this way. So this will become ascending powers of x, 2 minus 3x to the power 4. Okay, and plus 1 over ax is this. Alright, where a, b, c are integers, find the values of a, b, and c. So let's write this one in ascending powers of x. 16 minus 96x plus 216x square. I'm not sure which one will fulfill this question. That's why I'm writing all of them. Multiplied by 1 plus a over x. Alright, these are the first three terms. So let's see which one will give us this first one, which is 32 over x. We want a denominator x. Will this give us denominator x? Any one of them? No. This will give us denominator x, a over x, right? But this must multiply with one of them to give a over x, something over x rather. So which will be giving you something over x? Only the constant part. If this multiplies, this a over x multiply with any other, it will never give you something over x. So 32 over x will be because of 16 multiplying with a over x, no one else. Alright, so both of them have x, so let's multiply both sides by x so that we get rid of x's, both sides. So 32 equal to 16a, and that gives us a equal to 32 over 16, which is 2. This is the value of a. Got it. B is a constant. Can you see? B is a constant. What will give you a constant? Let's see. If 16 multiplies with 1, it will give you a constant, right? So 16 multiplied by 1 is 1. What else will give you a constant? A over x multiplied by 96x, because x and x will cancel out. So let me write that also. It is minus 96x multiplied by 9, no, not 9, a over x. And a is known to us now, 2 over x, equal to b. So x and x cancel as expected, and it will be 16 minus 96 times 2 will be 192 equal to b, and 16 minus 192 will be 176 negative. So we got the value of b as well. Cx. Now it will be easy for you to guess what will give you something x. So 96x, if it multiplies with 1, it will give you an x. So minus 96x multiplied by 1. What else? A over x, if it multiplies with a square, it will give you x, because this x will cancel out with one of the x's. So let's do it. 216x square multiplied by a is 2 over x is equal to cx. Yeah, that's what cx is. And now we can see that it is minus 96x. This square cancels with this x, so 216 times 2 positive will be 432x equal to cx. And now we can divide all of them by x so that we get rid of x's. So now what do we get? We get minus 96 plus 432 will be 336 equal to C. We got our C also. Question number 3 is about an identity. They're saying that left hand side is equal to right hand side. Prove that. Okay, let's do that. So 1 over, this is left hand side. Secant x minus 1 plus 1 over secant x plus 1. We want to merge them so that they become one entity like this. So let's try to simplify this by multiplying each other by their denominators. So this will be multiplied by secant x minus 1. This will be multiplied by secant x minus plus 1 rather, and so on top as well. Secant x plus 1, secant x minus 1. Effectively, we have multiplied them by 1 because secant x minus 1, secant x minus 1, they cancel out and we are left with this, but we will not cancel them out. We did not multiply them to cancel out. Okay, so now we'll multiply the denominator, and we know this identity: a plus b, a minus b equal to a square minus b square. This is a very famous identity. We will use that here. It is like a plus b, a minus b in both cases. So it will be a square minus b square. 1 square is 1. All right. What is left on top? Secant x plus 1 plus secant x minus 1. I made them 1 because their denominators are same now. So they cancel out 1 and minus 1. We are left with 2 secant x over secant square x minus 1. But it does not match with our RHS. Okay, that means we need to do something more, and we have some identities. Secant square x minus 1 is tan square x, and 2 secant x is 2 secant x. It is still not matching. 2 is 2, but everything else is not. But we can do it. So 2 secant x is reciprocal of cos x over tan square x is reciprocal, not reciprocal, equal to sin square x over cos square x. So can we write this as 1 over cos x, rather 2 over cos x, right? 2 multiplied by 1 is 2 over cos x divided by sin square x over cos square x, right? So 2 over cos x multiplied by cos square x over sin square x. 1 of the cos x will cancel with this cos x. So we are left with 2 cos x over sin square x, and we are still not there yet. But if you see, we need cot x and cosecant x, and that's what we can do here now. We can write this as 2 cos x over sin x, only one sin x. Remaining sin x I will write separate. Right? I've broken this sin x into 2 parts. And this cos x over sin x is cot x. 1 over sin x is cosecant x. We went through a lot of steps. There may be other ways also, but what I go with the flow. If it is not matching, something will make us reach there. And that's how we reach here. This is what we wanted, right? Okay. Let's see what else they're asking us to do. Hence, solve the equation, the left side of the previous part equal to 3 secant x. And we got this one as 2 cot x cosecant x, right? Equal to 3 secant x. This is what they want us to solve between 0 and 360 degrees. So since cot, cosecant, secant are all different, let's combine them by converting to sine and cos. So back to cos x over sine x, 1 over sine x equal to 3 over cos x again. Yeah. So can we, yeah, sine over cos can become 10, right? All right. So do this way, 2 over 3. Let me, so let's collect sine and cos on one side. So cos x goes and multiplies with this cos. It becomes 2 cos square x over sine square x equal to 3. Let's get rid of this 2. So divide by 2 here, divide by 2 here. So 2 and 2 cancel out. Cos square over sine square is cot square x equal to 3 over 2. But cot is not in our calculators. That means we will have to reciprocate it to get tan square x. So if 1 over tan square x is over 3 over 2, then I'll have to reciprocate both sides again so that I get a proper tan square x equation. So I equated cot square equal to 1 over tan square. They are equal, so I did not reciprocate 3 over 2, right? But now I actually reciprocated. Tan square came up, 1 went down, so 2 and 3 must also be reciprocated. And now to get that, we have to square root both sides. So tan x equal to plus minus square root 2 over 3. This is the simplest form we have for the equation, and now we will see that because both plus and minus are there, tan is positive here as well as here, negative here, and here we will get answer in all 4 quadrants. Only thing we need now is to find tan inverse square root 2 over 3, which will be equal to all x values we will have. I have not written minus here or plus here because quadrants are decided, so there is no need to write any sign. Let's see what tan inverse square root 2 over 3 is. By the time I find this, I would request you to subscribe to my channel, like and share this video with your friends so that they also get benefited and the knowledge is spread out all over the world. Thank you. And what I got is x equal to 39.23 degrees. I will use only 3 significant figures. So the first answer, 39.2 here. So this becomes our first answer. From here till here is first answer, which will be x1. I will write that as it is itself 39.2 degrees. x2 will be from 0 till the second line. And we know this angle is 180, so this line is 39.2 lesser than 180. So it comes out to be 180 minus 39.2, which will be 140.8 degrees. Third answer will again go further and reach this line, which is 39.2 more than 180. Yeah, and third answer goes to be 180 plus 39.2, which is 219.2 degrees. And finally, fourth answer will be here, this line, which is 39.2 lesser than 360. And that will give us the fourth answer and final. x4 equal to 360 minus 39.2, which will be 320.8 degrees. These are the 4 solutions of this question. Question 4a. Find the x coordinate of the stationary point on this curve and x is greater than 0. So if we get an x value greater than less than 0 or 0, we will not accept it. That's what it means. So, to find stationary points, we should ensure that dy over dx, the differentiation of this function, is equal to 0. Why? Because at stationary points, the tangent is a horizontal line whose gradient is 0 and dy over dx is the gradient. So let me differentiate this one. Y equal to 3 ln x plus x square minus 7x. So dy over dx will be 3 is a constant, so it remains 3. Differentiation of ln x is 1 over x. Then differentiation of x square will be 2x, and differentiation of minus 7x is minus 7. We will make it equal to 0 to get the values of x. So what are we left with? 3 over x plus 2x minus 7 equal to 0. This denominator of x is creating trouble, so let's get rid of this by multiplying the whole equation by x. Whole means whole of it, each individual term. So 3 over x multiplied by x, when we multiply, this x cancels out with this x and we are left with just 3. 2x multiplied by x is 2x squared minus 7x equal to 0, and that becomes a quadratic equation now. 2x squared minus 7x plus 3 equal to 0. You can use your calculator to find the values of x. Now I will use the factorizing method as usual. So this is how it will be. I am trying to factorize the whole of the left hand side. So these are the two factors I'm getting. 2x minus 1, x minus 3 equal to 0. So this gives us 2x minus 1 equal to 0, and x coordinate of this is half. This gives us x minus 3 equal to 0. X coordinate is 3. They're asking us to find the x coordinates of the stationary points, and we found them. Both of them are greater than 0, so both of them are good. Determine the nature of each of these stationary points. Okay, so we have x coordinates. These two, we'll have to find the nature. And what do they mean by nature? Nature is either maximum or minimum. That means this is a maximum, this is stationary point, this stationary point is minimum, and that's what we have to look here. And to find the nature, there are many ways, and I'm trying a new way, which I've not used in my videos. So let me use that one now. What I will do, we know at this maximum point, dy over dx is 0. What about just before this? Here, the graph is going up, so it will be positive. Graph is going down, so dy over dx, the gradient of the tangent, will be negative. So what will we do? We'll take a number on the left of half and one on the right of half and substitute not in the main equation. We'll substitute in the equation dy over dx. This was the one, correct? I can say this one. Just substitute in dy over dx. If it is positive, that means before that point the graph was going up, and if it is negative after that, it's going down. Obviously it will be going down after that. So let's do that. This is the equation. I'm substituting half, one number that is less than half. Since the number has to be more than 0, so let's say 0.25, 1/4. So 3 divided by 1/4 plus 2 times 1/4 minus 7. This was dy over dx, and we are interested in only the sign, not the value. Okay? So 3 over 1/4 will be 12, plus 2 over 4 will be half, minus 7. So 12 minus 7 is 5, 5 plus half is 5.5. So this is positive. It is increasing before half. So let's write this is half. Before half is increasing. Obviously after that it will be decreasing, but let's confirm a number more than half. Let's say 3/4. So we'll substitute 3/4 in the same equation, or rather expression now. 3/4 minus plus 2 3/4 minus 7. So this will be 12 over 3, 4. There will be 6 over 4, 3 over 2 minus 7. So this is not even 5. So minus 7 will give us a negative gradient. So yes, after half is a gradient is negative. That means before x equal to half, it was increasing. After that, it was decreasing. That means we have a maximum here. Let's repeat the same with 3. So first I will take 2.5, which is on the left. Rather, let's take very close to 3. 2.9. Let's take 2.9 and substitute in the equation we had earlier. 3 over 2.9 plus 2 times 2.9 minus 7. So 3 over 2.9 is almost 1. Let's call it 1. You can use your calculator, okay? I'm just rounding out. 2 times 2.9 will be 5.8 minus 7. So it will be 6.8 minus 7 negative. That means if x is 3, before that the graph is decreasing because the gradient is negative on its left. Let's see what happens after 3. Let's say 3.2. That is the number, okay? So I'll substitute 3 over 3.2 plus 2 times 3.2 minus 7. 3 over 3.2 will be almost 0.9 plus 6.4 minus 7. It will be 0.9 plus 6.4 is 7.3 minus 7, 0.3 positive. That means after 3 it is increasing. Before 3 it was decreasing. That's why it is a minimum. I have used other methods in other videos. This is one I thought you should be aware of. Next question. Solve the simultaneous equation. This one. They are creating trouble here. E to power x, e to power y, they are creating trouble here. So the best thing is, let's assume e to power x equal to m, e to power y equal to n. When we get their values, we'll go back to x and y. Alright? So it gives us two simultaneous equations, m plus n equal to 5, 2m minus 3n equal to 8. So I want to use elimination method for this. So what will I do? I will multiply this by 3 so that I get 3n, positive 3n here, so that I can cancel it. So it will become 3m plus 3n equal to 15. The question number 1 has changed. And now we can add. Some of you are used to subtracting, but because the signs are already opposite to each other, so I don't want to subtract. We can add also, right? So they cancel out. So what are we left with? 5m equal to 23. So m is equal to 23 over 5 or 4.6. So that means e to the power x is 4.6, and we can find x later. Let's find n. And for finding n, I will use this equation. M plus n equal to 5. M we got 4.6 plus n equal to 5. So n becomes 5 minus 4.6, which is 0.4. E to the power y is 0.4. So to find x, we will remove e. When we remove e from one side, the other side becomes natural log 4.6, and similarly y will be natural log of 0.4. Let me use my calculator to evaluate these two. And by the time I do this, I request you to subscribe to my channel, like and share this video, and motivate me to make more and more such videos so that the knowledge is spread throughout the world. Thank you. I got x equal to 1.53, and here I got y equal to minus 0.916. Next question. Solve the simultaneous equation, this one. They are creating trouble here. E to power x, e to power y, they are creating trouble here. So the best thing is, let's assume e to power x equal to m, e to power y equal to n. When we get their values, we'll go back to x and y. Alright? So it gives us two simultaneous equations, m plus n equal to 5, 2m minus 3n equal to 8. So I want to use elimination method for this. So what will I do? I will multiply this by 3 so that I get 3n, positive 3n here, so that I can cancel it. So it will become 3m plus 3n equal to 15. The question number 1 has changed. And now we can add. Some of you are used to subtracting, but because the signs are already opposite to each other, so I don't want to subtract. We can add also, right? So they cancel out. 5m equal to 7. (22). So m is 22 over 5. E to power x is 22 over 5. Let's find n, and let's use the first equation to find n. M, which is 22 over 5, plus n equal to 5. That's what the first equation was. N is 5 minus 22 over 5. So n comes out to be 5 times 5 is 25, 3 over 5. And e to power y is 3 over 5. That's what it means. And now we'll find the values of x and y. So x becomes ln 22 over 5, y becomes ln 3 over 5. Let's see, are they saying exact value? No, they're not. So we can just use calculator to evaluate these two values. By the time I do this, I request you to subscribe to my channel, like and share this video, and motivate me to make more such videos for you guys to gain knowledge. Thank you. So what are we left with? 5m equal to 23. So m is equal to 23 over 5 or 4.6. So that means e to the power x is 4.6, and we can find x later. Let's find n. And for finding n, I will use this equation. M plus n equal to 5. M we got 4.6 plus n equal to 5. So n becomes 5 minus 4.6, which is 0.4. E to the power y is 0.4. So to find x, we will remove e. When we remove e from one side, the other side becomes natural log 4.6, and similarly y will be natural log of 0.4. Let me use my calculator to evaluate these two, and by the time I do this, I request you to subscribe to my channel, like and share this video, and motivate me to make more and more such videos so that the knowledge is spread throughout the world. Thank you. I got x equal to 1.53, and here I got y equal to minus 0.916. Okay, from simultaneous equation to single exponential equation, and we have to solve it. Both of them have e, so it should be easier to do. E to the power 2t minus 1 equal to 5e to the power 5t minus 3. The challenge here is that the exponent here is different, exponent here is different. They can't be interchanged. But what we can do, we can break this 5t into two parts, one of them being this, so that I can take something common. What I mean is this. E to power 2t minus 1, no change. 5 e to the power, can I write this as 5t minus 3 as 2t minus 1 plus 3t minus 2. 5t minus 3 is still the same, right? So, since these two parts are adding, now I can separate the two. E to the power 2t minus 1 equal to 5 e to the power 2t minus 1 times e to the power 3t minus 2. Now, most of you may think that we can cancel this. Both of them are multiplying the same thing, we can cancel this. But no, we should not do this. If you do that, we will lose. There is a chance that we will lose one of the answers. So what can we do? We can bring this to the left side and don't leave anything on the right side. E to the power 2t minus 1 was already here. And I will take 5 e to the power 2t minus 1 times e to the power 3t minus 2, which is equal to 0. And now we can factor this like we factor normal equations. E to the power 2t minus 1 is in both, so keep it out. So what will be left? 1 minus 5 e to the power 3t minus 2 is left here, right? Now, there are two factors which are equal to 0. That means individually they will be equal to 0. So e to the power 2t minus 1 equal to 0. Unfortunately, no power of e can make it 0, so this is invalid answer. Even though we did not cancel them out, but we did not get any answer. But it's okay. Please make it a habit not to cancel. This one will be 1 minus 5 e to the power 3t to the power minus 2 equal to 0. And now we can write 1 equal to 5 e to the power 3t minus 2. After cancelling them, we would have gotten the same thing again, but still I ensure that there is no other answer which is lost. Okay, let's divide both sides by 5 to get rid of this 5. So 1 over 5 is equal to e to the power 3t minus 2. Now to get rid of e 3t minus 2 will be alone, and this will be ln 1 over 5. And let's complete it here. Ln 1 over 5 plus 2 equal to 3t. Let's divide both sides by 3 so that t is isolated. This 3 and this 3 cancels. So t equal to 1 over 3 ln, and 1 over 3 is with the whole of it, ln 1 over 5 plus 2. Okay, this should be here as well. So, have they asked us to find the answer in exact form? No, they have not. So we can find the decimal also. Just put this in your calculator and you'll get the values of t. One I got was 0.13. Next one is this. Do not use a calculator in this question. All lengths are in centimeters. Okay, and they have given the values of sin 60, cos 60 and tan 60 as well. Diagram shows ABC with these sides. Okay, angle is also given. Find the exact length of BC. So since this BC is opposite to the angle, we can use cosine rule. And what does cosine rule say? It says a square equal to b square plus c square minus 2bc cos a. Angle A is opposite to small a. So angle A is 60 for us, and small a is the unknown side. Let's call it A. So what does that become? a square equal to, b and c are the other sides, which are square root 6 minus square root 2 square plus square root 6 plus square root 2 square minus 2 times square root 6 plus square root 2 square root 6 minus square root 2 cos an angle is 60 degrees. So what is unknown in this? Only a square, right? So we can square this first. So a square equal to, you may know this identity, a minus b whole square is a square plus b square minus 2ab. So if we use this identity here, it will be square root 6 square, which is 6, plus b square, which is square root 2 here in this case. So square root 2 square is complete 2, minus 2 times square root 6 times square root 2, which is square root 12. Now here we'll use a plus b whole square. Let's make it plus. So this will also become plus. So what will be the square of square root 6? Again 6, again 2, but this time it will be 2 square root 12 positive, right? Now minus 2 is minus 2, let's keep it minus 2, and this is a plus b, a minus b format. There is one more identity, a plus b, a minus b is a square minus b square. No need to multiply them individually. This is the identity. Just write square of the first term minus square of the second term, which is square of 6 again, 6 minus square of the second term, 2. That's it. And cos 60. Cos 60 is half. Alright, let's see. 6 plus 2, 8 plus 8, 16. Minus 2 square root 12 plus 2 square root 12 cancel out. This 2 and this 2 also cancel out. We're left with minus this one, 4. So a square rather is 12 and a is square root 12. Length cannot be negative, so I'm not taking the plus minus root. It will be positive square root 12. That is the length of a. And they're saying find the exact length of BC. You can leave your answer as square root 12 or convert it to square root 4 times square root 3. Square root 4 is 2. Square root 3 is square root 3. That is the answer. There is another part to this question, which is show that the sine of the angle ACB, this one, is this. Alright. So since we use cosine rule, we got a side. Let's use sine rule to find the angle, this one. Sine rule says sine of angle A over A equal to sine of angle B over B equal to sine of angle C over C, where A, B, C are the angles and sides opposite to each other, right? So we know this angle 60 degrees, angle A. So sine A, sine 60 over A we just got it, 2 square root 3 equal to the angle we want to find, sine angle C, right? ACB over what is the side opposite to this angle? Square root 6 plus square root 2, right? Sine 60 is given here. Sine 60 is square root 3 over 2. So square root 3 over 2, and 2 square root 3 is already in denominator, so we will write that further, equal to sine ACB over square root 6 plus square root 2. Square root 3 cancel with this, and this square root 6 plus square root 2 can go and become numerator here. So sine ACB will be square root 6 plus square root 2 over 4, and I think this is what they are asking us to show. Yes, square root 6 plus square root 2 over 4. Done. There's one more part. Show that the perpendicular distance from A to BC is 1. So let's see what they're talking about. BC is this line, A is here. So they want this perpendicular line and they want to tell us that this is equal to 1 and we have to show this. We can't use this, but we have to show this. Alright, can I focus on this triangle? Look at this triangle. This, and this. Let's call the height that they are asking as x. This is the perpendicular distance, which is x. Okay? So sine of ACB, let's not call it B, let's call it M. So ACM, because B is out of this triangle, so let's not use it. Sine of this angle will be what? Opposite, which is x, over the hypotenuse, which is square root 6 minus square root 2. Correct? Sine ACM, we already found it. Sine ACB is same as sine ACM. Square root 6 plus square root 2 over 4. That is sine ACM equal to x times square root 6 minus square root 2. Right? So now we'll find x because we know everything. We'll do this cross multiplication first. And it is again the same thing. A plus b, a minus b, when I multiply square root 6 minus 2 with square root 6 plus square root 2. So let me do it down there. Square root 6 plus square root 2 multiplied by square root 6 minus square root 2 over 4 equal to x. And we got this earlier. It will be square root 6 square, which is 6, minus square root 2 square, which is 2 over 4 equal to x. 6 minus 2 is 4, 4 divided by 4 is 1. We showed it. In question 7, it is given that the second derivative is equal to this expression. Find the expression for dy over dx. So, to find dy over dx from d square y over dx square, we integrate it with respect to x and we get dy over dx. So what we'll do, we'll integrate the right side as well. E to the power 2x, let me separate the two, plus 1 over x plus 1 square dx. Because they're adding, we can separate them like this. So the integration of d square over dx square will be dy over dx, that's what they want, equal to integration of e to the power 2x will be e to the power 2x itself, but divided by the differentiation of exponent, which is 2. Plus, can I write this one as x plus 1 to the power minus 2? And we'll integrate this one. Whenever we integrate a linear expression with a power, we add 1 to its power and divide it by the same power we got. Further, we divide the whole expression by the differentiation of what is inside. Differentiation of x plus 1 luckily is 1, so that doesn't make any difference. Okay, then plus c. dy over dx equal to e to the power 2x over 2, and this will be x plus 1 to the power minus 1, and the denominator will be minus 2 plus 1 is minus 1. So this positive sign becomes negative sign, and we'll be left with x plus 1 to the power minus 1 only plus c. Now they are saying that dy over dx is 2 when x is 0. That information is given to find c. So dy over dx is 2 when e to the power 2x x is 0. Minus 0 plus 1 to the power minus 1 plus c. Okay, so 2 equal to e to the power 0. It will be overall 0, 1. So half minus, it will be 1 to the power minus 1, 1 plus c. Half minus 1 is minus half, but when it goes to the left side, it becomes positive half. So c comes out to be 5 over 2. And the final equation they want for dy over dx will be e to the power 2x over 2. I'm looking at this one. Minus, since this exponent is negative 1, to make it positive, I'll make it a denominator. 1 over x plus 1. And now see, already we have 5 over 2. Next part. Find an expression for y as well. So we can find it with the help of what we got earlier. Let's integrate this further and we'll get an expression for y. And they have given some information to find the second c. Alright, so integration of dy over dx with respect to dx is e to the power 2x over 2 minus, let's write dx here, 1 over x plus 1 dx plus 5 over 2 dx. Alright, this dx and dx cancel, the integration of dy is y. And they want an expression for y. Good. E to the power 2x will be integrated as e to the power 2x over 2 again. And we already had a denominator constant 2 which will not be touched, so we'll just multiply it with the new denominator. Minus, again x plus 1 can be written as x to plus 1 to the power minus 1, but if I add 1 to it, it becomes 0 and divide by negative 1 plus 1, which is 0. So no, we can't use the same method here because it is a linear denominator. For this, we do just ln x plus 1 divided by the differentiation of the content again, which is 1. There is no need to divide by 1. Plus 5 over 2 x plus c. Now to find c, they have given information y equal to 4 when x is equal to 0. E to the power 2 times 0 over 4 minus ln 0 plus 1 plus 5 over 2 0 plus c. Okay, e to the power 0 is 1. So 4 equal to 1 over 4. 0 plus 1 is 1 and ln of 1 is 0. Gone. 5 over 2 times 0 will also be 0. So we'll be left with only c, which was here. So c is 4 minus 1 over 4, which is 15 over 4. So the final equation of y, we will write with the help of this one. Y equal to 1 over 4 e to the power 2x, that's what we can write at, 2 times 2 is 4, minus ln x plus 1 plus 5 over 2x plus, right? Yeah, 15 over 4. That's the final equation. Question 8. Variables x and y are such that when square root y is plotted against log base 2 x plus 1. So square root y here, log base 2 x plus 1 here. We get these 2 points on the graph. 2, 10.4, let's say 2, 10.4 is here. And we have 4, 15.4 here. Find square root y in terms of log base 2 x plus 1. Okay, they are the actual ones which are here. But to make it simple, let's write capital Y in place of this and capital X in place of this one. That will make our expression or equation easy. So we know the equation of a line is y equal to mx plus c. So y is y equal to m, gradient. Gradient is y2 minus y1 over x2 minus x1. That's how we find gradient. Here it will be y2 will be 15.4 minus 10.4 over 4 minus 2. So that comes out to 5 divided by 2. So gradient is 5 divided by 2 x, and now what is left is c. To find c, we can substitute any of the 2 points into the equation and we'll get it. Let me choose the easier one. So 10.4 4 equal to 5 over 2 times x. X is 2 plus c. 2 and 2 cancel out. So 10.4 minus 5 equal to c, and c becomes 5.4. So the equation of this line becomes y equal to, not m, we know m now, 5 over 2 x plus 5.4, and let's substitute the values of real x and y's. The capital Y was square root y equal to 5 over 2 x is log base 2 x plus 1 plus 5.4. This is the equation of the given graph. What's next? Find value of y when x is 15. So square root y equal to 5 over 2 log base 2x plus 1 plus 5.4. X is 15. So we will substitute 8 by 15. Log base 2, 15 plus 1, 16 plus 5.4. What exponent of 2 is 16? That's how we can evaluate this. 2 to the power 4 is 16. So in place of log base 2 16, we will write just 4 now. If you are not sure how to do this, you can use calculator simply. So 2 and 4 cancel, we get square root y equal to 10 plus 5.4, square root y equal to 15.4, and to find y we have to square both sides, which is y equal to 237.16. Let's see what is the next question. Find the value of x now when y is 25. So square root 25 equal to 5 over 2 log base 2 x plus 1 plus 5.4. Square root 25 is 5. So 5 minus 5.4, I brought this plus 5.4 to the left side, equal to 5 over 2 is not going to cancel, I think, so I'll convert it to decimals. Log base 2 x plus 1. 5 minus 5.4 will be minus 0.4, and let's divide both sides by 2.5. So it becomes minus 0.4 divided by 2.5 equal to log base 2 x plus 1. This will be minus 0.16. Okay. So equal to log base 2x plus 1. To remove this log, the other side will become the exponent of 2, the base on this side. Alright. And log is gone, x plus 1. So x will be 2 to the power minus 0.16 and minus 1. So finally x comes out to be minus 0.104. Question 9 is asking us to find the equation of the normal to this curve at 1, 4. Nothing can be straightforward more than this. So to find equation of normal, we should know what is equation of a normal. How does it look like? It looks like this. Here x1 and y1 are the actual points on the curve, which we already know, 1 and 4. So in place of y1 we will write 4, in place of x1 we will write 1, and there is no need to write anything in place of y and x because they are journal points. Okay, so only challenge left here is to find m. M is nothing but the differentiation of the given curve, also the gradient of the tangent at a specific point, and here we want it at x equal to 1. X coordinate will be used here. So gradient of tangent is m, so minus 1 over m will become the gradient of the normal. So dy over dx of this particular function will be dy over dx equal to 3x square plus 2x minus 4. We'll substitute x equal to 1 now, and we'll get the specific gradient of the tangent at that point. So at x equal to 1, it becomes 3, 1 square. 1 square plus 2 times 1 minus 4. So 3 plus 2, 5 minus 4 equal to 1. So we get here 1 over 1, and negative is already there, which is 1, actually negative 1. So what is the equation of the normal? Y minus 4 equal to minus x plus 1. And if we put everything to the left side, it becomes x plus y minus 4 and minus 1 minus 5. This is the equation of the normal. Here is the B part of the same question. Do not use calculator, they are saying. So we have to show every manual working rather. Find the x coordinate of each of the following points where the normal cuts the curve again. So if this is the curve and this is the tangent at a certain point, so the normal will be this one. This normal is intersecting with the curve again at certain point, and they are asking us to find the x coordinate of that point. So the equation of normal, we just got it, x plus y minus 5 equal to 0, right? Yeah. Now what was the equation of the curve? It was x cube plus x square minus 4x plus 6. X cube plus x square minus 4x plus 6. And we want the point of intersection of the two. So what can we do? This equation was y equal to. Let's isolate y in this equation and substitute in place of this y, because at this point both of them have same y, whatever is that. This is the y value, it will be same. So I'm isolating y. So y will be minus x plus 5, right? If I put x and minus 5 on the other side. Now let's substitute in place of this y. So minus x plus 5 equal to x cube plus x square minus 4x plus 6. They are equal now. And now bring them to the right side again. So 0 equal to x cube plus x square. Now this is minus 4x. This minus x will become plus x when it comes to the right side. So minus 4x plus x. Let's write here plus x, and this is gone. Minus 4x plus x will be minus 3x. This plus 5 will become minus 5 when it comes here, so it becomes plus 1. And now we have to solve this equation to get the x coordinate of the other 2 points. X equal to plus 1 is a root of the equation we got, right? That means if x equal to 1 is the root, x minus 1 is the factor. When something is a root, it makes the polynomial equal to 0. So if you write x equal to 1 and put x to the left side, it becomes x minus 1 equal to 0. So that means x minus 1 will make the whole of it equal to 0, and that's what it did. It gave us this equal to 0. So now we have to find other factors. So we got x coordinate equal to 1, that is 1. And let's find the other by long division. X cube plus x square minus 3x plus 1. Okay, so x square will be x cube minus x square. So minus and plus, they cancel out. 2x square minus 3x plus 1. We multiply by 2x now to get 2x square here, and we'll get minus 2x here. Cancel. Minus x plus 1. Minus 1. Minus x plus 1. Plus minus cancel. So this is our second factor. One factor was x minus 1. Let's see if it can be factored, because if you notice the question, they said it here. Find the exact x-coordinate of each of the 2 points where the normal cuts the curve again. So that means we should get 2 more answers. One is x equal to 1 already, because look, they had already given x equal to 1. Look here. So it was not a news. X equal to 1 was not a news for us. What will be news? The factors of this. Let's use quadratic formula to solve this one. So quadratic formula says minus b, 2 is b for us, plus minus square root b square minus 4ac over 2 times 1. So it comes out to be how much? Minus 2 plus minus 2 square is 4, that is plus 4 over 2. So minus 2 plus minus 4 plus 4 is 8, and if I write 8 as combination of surd and complete number, it will be 2 square root 2 over 2. We can see all of them have 2. We can cancel such situation. Whenever there is a plus minus, it's not possible to cancel two numbers, but it is possible to cancel all of them if possible. And in here it is possible. This 2, and this 2 cancel out. So we are left with minus 1 plus minus square root 2. So they are asking us the x coordinates of the other 2 points where this normal is crossing the curve again. So one is this, one is this. This is a symbolic curve, okay? It is not the actual curve. So those two x coordinates are x coordinates of the 2 points of intersection are minus 1 plus square root 2 and minus 1 minus square root 2. Question number 10. The first 3 terms of an arithmetic progression are x, 5x minus 4, and 8x plus 2. X is unknown, right? They're asking us to find x and the common difference, all right? So let's take the help of common difference to find x. How come? We can write that the second term, a2 minus a1, isn't it equal to d? So is a3 minus a2. Basically, the difference between the 2 consecutive terms is d. And we are equating them. Just put them like this and you'll get a value of x. a2 is 5x minus 4, second term, minus a1, which is the first term, or ax, equal to a3, 8x plus 2, minus a2, 5x minus 4. I put this bracket because the whole of it will be subtracted. If I don't put bracket, I did not put any bracket here because x was just one term. But here there are 2 terms, both should have this negative. So 5x minus x is 4x minus 4 equal to 8x minus 5x, 3x, 2 minus 4, 6. 2 plus 4, 6. Now let's put x's together. 4x minus 3x equal to 6 plus 4. And 4x minus 3x is x equal to 6 plus 4, 10. Got the value of x. But they're also asking common difference. So we can use one of the sides because we said a2 minus a1 is d. We can put the value of x in left side only and we'll get common difference d. So dx will be 5x minus 4 minus x, and x is 10 for us. So d will be 5 times 10 minus 4 minus 10, which is 50 minus 4 and 10, 14. So d comes out to be 36. B part, similar situation as A part. It is the first 3 terms are these. Find the 2 possible values of y. They are not asking common ratio, but common ratio is the one which will help us to find our y. How? Common ratio r is the second term divided by first term, or third term divided by second term. So in part A, in arithmetic progression, we subtracted, here we are dividing. So let's see A2, 5y minus 4. A1 is y equal to A3, 8y plus 2 divided by 5y minus 4. Let's carry out cross multiplication to make it a simple equation. So 5y minus 4 was this, right? So 5y minus 4 square, because both are same. So square of 5y minus 4 equal to y multiplied by 8y plus 2. So we can use the identity a minus b square in this. I have repeatedly used this identity in this exam, in this paper solution. So please, you can look at the previous questions. I'm straight away using it. This is a for me, this is b. So 5y is a, its square will be 5y square, which is 25y square. Square of 4 will be 16 minus 2 times 5y times 4 equal to y times 8y will be 8y square on the right side, and y times 2 will be 2y. Let's expand this and bring everything to the left side. 25y square minus 8y square plus 16 minus 2 times 5 is 10, 10 times 4 is 40y, and this 2y will also come to the left side, 2y. So 8y and 2y, 8y square and 2y, both of them have come to the left side, and let's simplify this. This becomes 17y square minus 40 and 2, 42y plus 16 equal to 0. And now you can use your calculator to find the two possible values of y. However, I will use the factoring method. I know some mental ways of doing this. You don't have to worry. You can use your calculator which has capability of doing this. So I will just perform this factoring. So 17y, y minus 2 minus 8y minus 2 equal to 0. So two factors I get, 17y minus 8 and y minus 2 equal to 0. So this gives us 17y minus 8 equal to 0, 17y equal to 8, and y equal to 8 over 17, which is less than 1. Interesting. Y minus 2 equal to 0, which is y equal to 2, which is more than 1. Wow. These are the two possible values of y. You might be surprised, why am I saying wow when I saw these two? Because one is more than 1, which will make the sequence more and more. One is less than 1, which will make it less and less, and still the relationship works. That's why I'm surprised. Okay, let's go to the next part, which is this. For each of these values of y, 8 over 17 and 2, find the corresponding value of the common ratio. Alright, so that means we have to go back to our initial equation we made. So we can use this one. R equal to A2 over A1. A2 is 5y minus 4. We can use only 1. Okay. So R equal to 5y minus 4 over y. Right. So let's use 8 over 17 first. So R, if we write if y is 8 over 17, this will be what? 5 times 8 over 17 minus 4 over 8 over 17. So 17 times 4 is 68, and 40 minus 68 is minus 28 over 17. Pardon me if you're not understanding what I'm doing, just put this in your calculator and you get your answer. I like doing manually. If it is too difficult, I will use my calculator, but yeah. 17 and 17 cancel out, it becomes minus 28 over 8 or 7, 2. So the common ratio in case of y being equal to 8 over 17 is minus 7 over 2, and let's do the same thing if y is 2. So r becomes 5 times 2 minus 4 over 2. 10. 10 minus 4 is 6. 6 divided by 2 is 3. Straight away. R is 3 in this case.